In our last video, we used this table to talk about super shoppers. We were given the midpoint ages of those super shoppers and what percent or what probability of shoppers fell into each one of those age categories. Today we're going to use that same information. We're going to draw our mound shape distribution, and then we'll talk about Chebyshev's rule and the empirical rule and compare what percent of our super shoppers fall within 1, 2, or 3 standard deviations of the mean. So let's get started with drawing the curve. Now that we have our distribution drawn and the standard deviation bars marked, we can place the values under the curve where they fall. We know that mu represents the expected value. So let's place 41.26 under the curve. Now we'll use the standard deviation to label the other x values under the curve. The standard deviation is 11.87. So to label values to the right of the mean, we'll be adding 11.87. So let's label those. To label the x values to the left of the expected value, we subtract the standard deviation. All of the x values have been labeled. Let's look at what the x values are of super shoppers within 1 standard deviation of the expected value. So the ages of those shoppers would be from 29.39 to 53.13 years old. We can look at our table and see that age 31, 40, and 49 all fall within this region. So all we need to do is add the probabilities associated with those ages, and we'll know what percent of our data falls within 1 standard deviation of the expected value. And that total is 0.77. So that translates to 77% of our shoppers fall between the ages of 29.39 years and 53.13 years. Since we're only looking at 1 standard deviation, we remember that Chebyshev's rule doesn't tell us much about that except for we should have more than 0%. The empirical rule tells us that at least 68% of the data should fall in this region. So we do have a high enough percentage to satisfy that condition. So this would follow the empirical rule. Let's look at what happens within 2 standard deviations of the expected value. This would include these regions I'm shading in green. So this would include the region 17.52 to 65 years old. So we don't have any super shoppers as young as 17, but our 22-year-old would be included, and so would the 58. So it looks like we already have 3 of the probabilities included, so we'll just add 0.05 and 0.11 to the previous total. So we had already 0.77, we'll be adding 0.05 and 0.11. So this total brings us to 0.93, or 93%. So if we look at Chebyshev's rule, that tells us that at least 3/4 of the data should fall here. So Chebyshev at 75%, so we have met that, and 0.95 or 95% for empirical rule. We're just a little short there, so this would be Chebyshev's rule. Looking at 3 standard deviations within the expected value now, let's find what the age cutoffs would be for mu plus or minus 3 sigma. That would include all the way down to as young as 5.62 years and as old as 76.87 years. So looking back to our data, the 67-year-old would fall within that boundary. Now, do you notice that would be every one of our super shoppers? So what should the probability add up to if this is including all of the shoppers? We should get 1. So we know that we already had 0.93 from the shoppers within 2 standard deviations, and the only value that wasn't included yet was the 67-year-olds at 0.07. So if we added 0.07 to the 0.93, that does make 1. So that would be 100%. So we could go back to saying this is the empirical rule. The empirical rule tells us that at least 99.7% of our shoppers would fall in this range. So we've met that criteria at 100%.